I'm going to do all of the quiz questions from Probability and Stats Quiz 9 now, because I thought that was the hardest one of them all, and as you can see at the top here, I did particularly poorly at the time, so it was well worth revising for me as well as everyone else. So we'll see if we can't nut out all the answers. This is question 1. Given a random sample of size n equals 200 from a non-normal population with mean, mu, and standard deviation, we conducted a large sample z-test of the hypothesis mu equals 2.4 as the null hypothesis, and the alternate hypothesis h1 mu does not equal 2.4. So it's a two-tailed test. We don't know the standard deviation of the population, and the observed value of the test statistic is minus 1.86. Determine the p-value of the test. Well, so even though we have a non-normal population, we've got a sample size of 200. So the central limit theorem tells us that once you get a sample size that big, it doesn't actually matter what the population distribution is. We're still going to end up with a normal distribution of the sampling mean. So I hope that makes sense. The sampling mean as distinct from the population mean. You have to keep those two things separate in your mind. So what we need to do is go look up the z value for a z of 1.86, and then bear in mind that we're looking for a two-sided statistic, and find a p-value for that. So we want to know what's the probability of having a z of an absolute value greater than 1.86. So let's go to the tables and have a look what we get. I'm going to look up negative 1.86 because that'll give me an absolute value. And if we come across to the tables we've been given, 1.86 will give 0.0314. So the probability of being less, well, let's just see what that's actually saying. We've got a bell curve like this, and we've plugged in negative 1.86, and the area of that there is given as 0. That's the one we've just calculated, 0.014. Sorry, 0.0314. So what we actually want is we want that one plus the equivalent on the other side, because we're looking for the two-tailed one, so we actually want the probability of it being more extreme than either 1.86 or negative 1.86. So all we need is p-value is going to be equal to 2 times 0.0314, which is going to be 0.0628. And we have the answer there, so yes, we've got this one right now.